Okay, now, as you can see, we are skipping a lesson because lesson 8, it's pretty easy. We'll do that tomorrow. Lesson 9, a little bit more challenging. I don't want to leave it for a Thursday. Okay? So timing is everything, and the timing was not good. We're working on word problems today, which, let's face it, not too many good things have the word problems in it. Okay? So when we're dealing with word problems, I think people get a negative perspective, or these are hard. And students typically, generally I would say, they don't like these because they're big paragraphs with information, and I gotta infer all this stuff, and it's weird. You probably don't even know how early it starts, but my son's in grade 2, and he's coming home, he's got these math problems he's got to do, and it's like, okay, you have 6 motorbikes, and you buy 7 more motorbikes, and then you sell 3. How many tires do you have? Okay. And then the next thing is, and if it's $65 a tire, how many $100 bills and $5 bills would that be? Okay. So they're not the problems that you would think would be happening in grade 2. Like if you had 10 motorbikes and you bought 4 and you sold 3, you're like, well, those are kind of lame, right? But to take it to another level where they don't say right in the question there's 2 tires per motorbike, you just have to know that from common knowledge. Okay? And and then it brings money into it. That's another twist. So right from the earliest ages, problem solving is put in there because it is definitely the highest level of learning. Okay? And problem solving has to do with any problem you have, be it financially, be it with friends, be it whatever. It's like, how do I fix this problem? Okay? Now, because students typically find getting a plan together very difficult, I'm going to teach you what I believe, because I've been doing this. I mean, you've been doing problems for 11 years, and I've been doing them for over 20. I have come up with some, I think, ways that students typically do better with problems, okay? So just bear with me. The first one, you'll kind of see what I mean, and then we're going to do a couple more. And then I'm going to get to another type of question that students really, really struggle with. And I'm going to show you a way to be able to get those, okay? And what I'm talking about, it's if one person takes, 45 minutes to mow a lawn by himself, and another person takes 30 minutes to mow a lawn by himself, how fast could they do it together? Okay, so if one did it in 45 minutes, another can do it in 30, together, how fast could they mow that lawn? Now, it's a nice short question, but students really struggle with finding the answer. Now, any guesses? I'm just throwing that out there. What would be a good educated guess for how fast it would be? Average it. That's the most common answer. Okay? Now, if you take the average of 30 and 45, what is it? 37.5. Why is it taking longer with 2 people? Divide by 2 again. Yeah, but the 2 people that are doing it at different rates. One is much faster than the other, isn't he? Or her. Okay? So why I bring this up is they always have one of these on the grade 9 achievement exam. Okay? And it may be 2 pipes filling a pool, one pipe alone can do it in this fast, the other one can do it this fast, how much together? Or two augers filling like a truck with grain. One can do it at this speed, the other classic is shoveling snow or mowing a lawn. Okay? So I'm going to show you how to do those. And that's one of the most difficult problems for students to get. Okay? In fact, I could probably give you the class because it's so easy to grasp the concept. Okay, these two people are like, we got to figure this out. It can't be 37 minutes because one can do it in 30. Guy comes along and he's slower. What's he doing, right? Is he like standing in front of my mower and says, "You can't go. We got to be here for 37 minutes," right? So let's get through a couple of the, and we're going to do these as a class, right? So I know we all like to hide. Please don't pick me. Please don't pick me. But we need to think about these together, okay? I think we've been in this long enough that I guess you guys can trust me that I'm not here to humiliate you. We need to work through this. Okay? Now, the distance, speed, time, we're going to work on those for the next 3 questions. Now, these triangles are bad. Okay? Never use a triangle to memorize stuff because here's the problem. This formula has 3 things in it. 99.9% of the formulas you'll be learning have 4, 5, 6 variables in it. So you can't use a triangle anymore. Okay? You have to know how to derive formulas. And hopefully you were taught that in Science 10. Okay? And then, of course, if you do it in physics, you're not using triangles, hopefully. So you need to know this formula. Okay? Dirt, D equals RT. Okay, you need to know that formula. If you know that formula, you can get all the rest by using algebra. Now, first of all, if I need to find distance, it's already in that form. If I need to find time, sometimes I need time by itself, right? Well, how do you get time by itself? Divide by R, right? Like, why do you need triangles? You should be learning how to think about this stuff. So you should always know your non-fractiony one, okay? Like I wouldn't me D over R equals T, like I like dirt, right? That's what I think, D equals RT. And ST is the same, S, speed, rate, okay? And it's not the same thing in physics, but, loosely, speed and distance, or speed and rate are pretty well the same thing for our purposes. The other thing that really, really messes with students' heads is the chart. Man, that actually does not work well, okay? And trust me, when I've been through it many years, I'm not trying to say I know everything. I'm just saying I know what doesn't work. I know what messes students up, okay? Now, remember what makes my job easier? When you guys are learning. So I'm doing this for both of us because you're going to learn it better and it's going to be less frustrating for me because I'm not going to have a bunch of students freaking out, okay? Because students freak out over problem solving, believe it or not. Want to see some emotions going on? This is where it happens. Now, again, the first one I'm going to do, and then we're going to do the others 2 kind of together. So I want you to kind of know the problem. We've got a race going on. Shannon cycled for 120 kilometers, then swam for 12 kilometers. Her average cycling speed was 8 times faster than her average swimming speed. Shannon took 9 hours to complete the race. Now, the first thing we're going to do is we need to get a simple formula. Now, with simple formula, it's one variable only. Now, what am I talking about? I'll show you. This is the simple formula, simplest that I can find, and that is time for cycling plus time for swimming equals 9 hours. Okay? Now, There's two things that I know there. I know that to be true for sure, and I don't know any of the times. If I knew any of the times, I'd put them in. Okay? It is the simplest formula up there. Now, so that would be my first formula. So a one variable formula. Now, I know this formula. D equals RT. So I'm going to continue. So this is like the cycling column. This is the swimming column. So I'm going to keep working down. So number 2, so this is where I do the simple, and then this is the complex. And then 3, we're going to substitute, and 4, we're going to solve. Okay? Now, since D equals RT, this is where I'm going to get the other variables involved, because T is D over R. Right? Does everyone see that? So, T is the same thing as D over R. Okay? So, since time plus time equals 9, D over R plus D over R must equal 9, right? Because D over R equals time, right? Does everyone understand that 1 and 2 are identical sentences? I can prove it mathematically. Those are identical statements. Now, what is the distance that she cycled? 120 kilometers. What was her rate? She cycled 8x. Okay. The distance that she swam. How far? 12 over x equals 9. Now, do you see that if I start with number 2 or number 3, students get very confused. But if you see my progression, like, do you understand that this all mean the same thing, and these all mean the same thing? So by my third step, you should go, okay, yeah, I buy into that. Right? Well, you got the 120 over 8x because D over R, and you got D over R because D over R equals T. Yeah, that's cool. Okay, that's what you've got to do every time. Simple, one variable each. Then get into it, the rest of the formula. Substitute, solve. Now, maybe even solving for this before yesterday would have been a problem, but this would have been an easy quiz question. What is my common denominator? 8x. So I'm going to multiply this by 8x, this by 8x, and this by 8x. Okay, now this one, 8x cancels. So I got, I guess I shouldn't have drawn these so low. Okay, so I got 120 plus the x's cancel in this one, right? What's 8 times 12? 96. Equals 8x times 9. 72x. So now it's pretty easy math at this point. 120 plus 96 is 216 equals 72x. Divide by 72. 3 equals x. Now the million-dollar question is, what is 3? What is 3? The speed she swam. Because look where my x is. It's right here. Okay? This is this, right? Now, how long did she swim? How long, time-wise? How much time did she swim? 4 hours. Yeah. Why? Because what is 12? You guys, look up here for a sec, okay? Remember, this equals this, right? So 12 over 3 is 4. So 4 hours. Okay? So I can ask lots of questions. I can ask, well, how fast did she bike? How fast did she bike? What speed did she bike? Let's do that first. 24, right? What's 120 divided by 24 will give me this. 5 hours. 5 hours plus 4 hours equals 9 hours. That works, eh? Okay? So, simple, then complex, then substitution, then solve. Now, sometimes there's more than one simple that works. But make sure your simple is correct. Like, can I put T time cycling equals time swimming? No. It doesn't say that. But sometimes it does say that. It'll say, yeah, the time on the train is equal to time in the plane and bus. Okay? So then you could go T that equals T that, right? And then you D over R, and then fill it in, and you'll get it. Okay? So what's the challenge? Coming up with a simple formula. After that, easy. And coming up with a simple formula isn't so bad either. Okay? So this one we're working together because I need someone to come up with the simple formula for me. So we got Students Council travel to Knoxdown, Harperville for Students Council National Conference. From their travel allowance allowed for the trip, St. Andrews Students Council has two options. They can leave tonight by bus, or they can save 3 hours by leaving tomorrow morning and using the express train, which travels 25 kilometers faster than the bus. Some of you guys even get like a sick feeling in your stomach when you read these things? Yeah, no? If the distance from Knoxdown to Harperville is 1,500 kilometers, determine how long it would take to travel by express train. Okay? What would be a simple, one variable, true problem or true statement? Don't be shy. Just joking. Okay, come on. Anything? Train speed equals x plus, but then you got train speed and x. You got two unknowns in there. Okay? Look for time. I'll give you that hint. Look for time again. Get it? Okay, so you're doing, that's quite complex what you're doing, right? Go simpler than that. One variable plus or minus another variable equals this, or this variable equals this variable. Keep it simple. Just trust me on this one. Don't try to, because I know you guys have all been down this path even last year, and you still haven't come up with a system. This is a system that always works. Okay? Tell me just the time. You can only, the sentence, the statement, the math can only have times in it. Okay? Or can we say, I'm going to do the same thing that you just said, but time of the bus minus time of the train equals 3? It's the same thing you were saying. You just put yours on the other side. That's it. The time the bus takes is 3 hours more than the train, right? So why did I put bus first? Because the slower should go first, right? That way you get a positive answer. Now, what does T equal? D over R, right? So we've got D over R minus D over R equals 3. And maybe you want to write this so you're always working down and not losing track of, that's D over R of the bus first. Okay? So 3, what is the distance the bus goes? 1,500. What's the rate? Okay? Minus, how far is the train going? 1,500 over. What would it be? X plus 25, right? It's going 25 kilometers an hour faster. Okay, common denominator, x plus x times x plus 25, right? So x times x plus 25, x times x plus 25, and x times x plus 25. Okay, the first one, the x's will cancel, so that'll be 1,500 times x plus 25. Next one, the, oops, 5. Next, the x plus 25's cancel, it'd be 1,500 times x equals 3 times x plus 25. Okay, now we got to work with this monstrosity here. Okay, so this one will be 1,500x plus 37,500 minus 1,500x equals 3 times x squared plus 75. X. Oops, almost missed an x there. Okay. Now on the left side, what's kind of nice there? Cancel. That's a beautiful thing. This is 37,500 is left, and this is 3x squared plus 75x. Okay, now we can't go and just make this x equals because we got two x's split up. So, yep. Yeah, I did. In my head, just not on paper. Okay, so I would have 225x, right? Well, no, so this should have been a 25 in the first place. Okay, that's where I'm going. Plus 75x. I'm like, huh, I've done this. This is my third time today. I never had that before. Look at what's going on. Okay, I am losing it. Now, let's get everything on the other side. 0 equals 3x squared plus 75x minus 37,500. Okay, what do we do to solve this? Divide everything by 3. Okay, so you can take this whole thing and divide by 3. Or just take out a 3, but when it equals 0, remember you can get rid of it. because you can divide both sides by 3. And this will give you x squared plus 25x minus 12,500. Okay, so you have to go, what two things add to give me 25 and multiply? And I'm just going to let you off the hook here. That equals x plus 125, x minus 100. So, what's x? X equals what? Negative 125 or 100. What is x? Speed, right? Speed of what? So negative 125 is not going to work. So speed of bus equals 100 kilometers per hour, right? Did it ask us that? No. To determine how long it would take. Well, how long would it take? How are you going to figure that out? You're going to just be in this column though, right? How long would it take to travel by express train? So how are you going to solve that? 1500 over 100 plus 25. So what is the time the train would take? 12 hours. How long do you think the bus would have taken? 15 hours, right? Does that make sense? Okay. Your next challenge. I need the simple equation for number 1. The simple equation for number 1. Look how short it is. 2 lines and a couple little words after. 3 little words. So it's really short. Come up with the simple one variable. Simple. Did I stress simple enough? I want it simple. This one actually has 2 that work very well. Okay, let me in on it. We'll do this together. Don't even make eye contact with me right now. Come on, what is it? Give me a simple formula. Yeah, that is the one I did. Okay, so time Evan equals time Megan. Okay, time equals, so remember, this is the Evan side, and this is the Megan side. The other 2 classes picked a different way. So C, can you see a different way after we do this one? So time, what does time equal? D over R, right? And keep your side straight. Now, distance that Tim went. When I mean, where'd Tim come from, eh? I just see this big T. The TM on the other side, that screwed me up. Okay, what distance did Evan go? Okay, what was his rate? X. Okay, and Megan went 329 over x plus 6. Okay, and then you get to do this, right? So 308 times x plus 6 equals 329x. So then we have 308x plus 1848 equals 329x. Now we can minus 308x to this side. And we get 1848 equals 21s. X. I used S in my book. So okay. So what does X equal? Divided by 21. 88 equals X. Now what is X though? Evan's speed. But it said calculate Megan's average speed and time. Okay, so what was Megan's average speed? How do you find that out? 88 plus 6, which is 94. How do you find out Megan's time? So Megan, so we're doing this, right? Which we know is this, which is time. So 329 over 94 is what? 3.5 hours. Okay, now what's another way we could have done this one? Okay, so if we take Tim's speed, Tim, where am I getting Tim from? Okay, so if I do speed of Evan minus speed of Megan, I should get 6, right? Yeah, Megan goes faster. Good. Tim's not coming this time. I got no T's on this side. I won't screw that up. Okay? Now, that would have been, so what is speed? D over T. So D over T minus D over T equals 6. So that's 329 over, what's the time? X minus 308 over X equals 6. Okay? So multiply everybody by. So 329 minus 308 is so we get 21 equals 6x divided by 6 divided by 6. What do we get? X equal 3.5. Sweet, eh? Okay, so you'll have time to practice these today. That's why I didn't want to do these tomorrow, because the bell would have rang about now tomorrow. Okay, and then it's like, well, we get these, okay, and then you're off, right? So that's not good. Now, I do need you to turn to the page right after your homework for 38. Okay, now, what I'm going to show you here is a way to do this type of question. The type of question I'm talking about is person A can do it in this, person B can do it in this, how much together? Or this pipe can fill it this fast, this pipe could fill it this fast. What if we had both pipes doing it? Or both augers filling a, truck, or, shoveling snow, whatever, okay? So these are going to we're going to call these like the shoveling, mowing, filling questions, okay? You'll know what they are every time you get one. Now, the best way to teach these is by an example. We're going to do 2 examples, so make sure your page, you cut it in 2. because I just figured out from the other class that you guys don't have this little extend page thing down there, which comes in very handy, let me tell you. Extend page. Might want to maybe get your parents to spend a little bit of money and get you that option. Okay, Christmas is coming. I'm just saying. Okay? Get it on the old Santa list. I haven't sent it out yet. Now, ready. Example 1. One pipe alone can fill a tank in 20 minutes. And another pipe alone takes 30 minutes. How long would it take the two pipes together? Now, one thing about this question, it's very easy for students to comprehend what's going on. Okay? Like visualize it, right? You can pipe fill in the tank, right? And then this one fills the outtakes. Okay, together. Oh. Okay. So, first of all, get sort of an educated guess. Now, if you go 20 plus 30 and divide by 2, you get 25. So finding the average of the two times, even though it is the most incorrect given answer, it shouldn't make sense, you guys. It shouldn't take 25 minutes if both are doing it. Okay? So what's an educated guess? Yeah. 12.5? 10, 14? 8? Okay. Are these probable, all of these? Yeah, they are. Yeah, 8's a little out there. Who said 8? Oh, man. Andrew. Okay. So, here's how to do these, okay? I guess I should ask, any guesses how we should try to do these? And this is one of the most incorrectly given answer for the grade 9 achievement exam, because these are on there. And B, most challenging for teachers to teach. So I'm going to teach you a way to do these every single time. Okay, there's one way to do these that I think students find quite simple, and it is using speed or rate. Okay, so let's talk about rate, because D equals RT what we'll be doing. So the rate of the one pipe plus the rate of the second pipe, or let's use speed. Speed of the one pipe plus speed of the second pipe should equal speed total. So it is a rate or a speed thing. It's actually the rates that add together, not the times. And why is this question so easily understood but so incorrectly given? Because people just look at the times. It's actually, they will get their rates together, not their times. Time is what comes out of it after. Oh, look, we did it in this day. We did it in this. That's way better. Okay? Or that's way faster, fill that. Now, what does S equal? D equals ST, so it would be D over T. So then we go D over T plus D over T equals D over T. Remember, that's just formulas, right? We can get stuff in. Now here is the other kind of weird thing that you need to know. First of all, speeds add together. The second thing is distance. Huh? We're mowing the lawn. Like, we have to measure back and forth, back and forth. Oh, we're filling a pool. Like, what's the distance? Okay? So we're going to count it as distance is going to be the job or the pool. Okay? Or the tank or the lawn. So it's always going to be one. Will always be. So what I'm trying to say is pipe 1 can do one tank in how many minutes? 20 minutes. The tank 2 can do one tank in 30 minutes. Together they can do one tank in X minutes. So this is the way to set them up. You add speeds together and then put ones for the D's. Okay? Now, there's two ways to do this. You can find a common denominator, or you can multiply everything by 60x, right? So multiply this by 60x, this by 60x, and this by 60x. So, what's 60x divided by 20? 3x plus 60 divided by 30. 2x equals 60x divided by x. 60. 3x plus 2x. 5x equals 60. Divide by 5, divide by 5. X equals, drum roll, and it is 12. Close. Okay? So kind of the only answer that was really whacked out was 8. Otherwise, it was pretty good. Yeah. 8 plus 4. That's awesome. Good job. Okay, so what does X stand for? Time total. Okay, so it would take 12 minutes together. Now, that's not really intuitive. I mean, I gave you guys chances to, like, would you have come up with 12 doing it maybe the way you're going to tackle it? Okay? So that's the trick. It's always going to be the same every time. So this is something you want to get on a study sheet, okay? I'm going to give one of these in the quiz tomorrow. Right? They're very easy questions if you know that it's rates we're adding, not times. Okay? We're going to do one more. That's why we split this in half. Okay? So, we got Peter and John and mow a lawn together. I know the suspense is killing you. In 24 minutes. Peter can do it himself in 40 minutes. How long would it take John by himself? Now, if you thought the other one was very incorrectly answered, this one is even worse. Now, without doing getting your calculator out, any guesses? $40? $60? Come on, ladies. What do you got to lose? Just your name spread all over the web? I mean, what? I won't say last names. 32. 45. Girls are still not guessing. Come on, Nancy. Just throw a number out there. Yeah. 38. Okay. So, what did I say is the main formula? So, speed of Peter plus speed of John equals speed together. Speed is d over t plus d over t. Now remember, stay in the right columns, right? So you don't mix anybody up, d over t. Okay, and again, we're putting ones because it's, one lawn. So Peter does it in what? 40. John does it in x. And together they do it in 24. Okay, now a fast way to do this one, you guys, is actually just minus 1/40th to both sides. Right? Just minus 1 over 40. So if you minus 1 over 40, 1 over 40, right? But if you're not going to do that, we can do it our normal way. But then we're going to have to come up with the common denominator 40, 24, and, okay? So minus 140 to both sides, and it is easier. And your calculator can do that. 1 over 24 minus 1 over 40, math, enter, enter. What do you get? Because then that's going to leave that out of there, right? One over 60. Okay, and then you just got to bring that up and that up. 60 equals x. Again, not an intuitive answer, right? No one would usually pick 40 and 60 to be 24. Yeah. Okay? So, I want you to get right at it. Actually, let's talk about number 4. Number 4. Now, number 4 is not a speed rate type of question, so don't go and do a simple, complex, whatever. This is just, I'm going to show you how to do this because this one, 2 consecutive even whole numbers are selected. Now, so if we've got the first number and the second number, well, the first one would be x. What would be the next consecutive even number? X plus 2. Okay, then it says the difference between the reciprocals. Difference is subtraction between the reciprocals. So 1 over x minus 1 over x plus 2 equals 1 over 60. Okay, it says the difference between the reciprocals of the two numbers is 1 over 60. And you're going to get 2 answers, but only one of them is a whole number. See, even whole numbers up there? Okay, so, yeah, work through them. You've got 20 minutes. Even if you just want to work on getting simple formulas for each question today, looking up here in the book and seeing if I have this, because I've put the simple ones in as well. And then tomorrow we'll have a quiz on it instead of the other way around, where we would have done this one tomorrow and then the whole weekend you would have went and maybe been frustrated or whatever. Tomorrow's a nice, easy lesson. What are we doing? We are doing 1 to 11. You can, I already did 1 for you. I'm such a nice guy. And omit 3 and 5. So basically 2 to 11. Omit 3 and 5. And I did 4 for you practically. I should get homework marks today.